Okay, that pretty much covers everything you need to know to do well in the midterm exam and the mid-semester project. If you wrote down all those answers I just gave you, you should be good. Okay, now then, close the infinite void. If we open up SolidWorks, we're going to move past the first two features. We're going to move past the ones that are so big they take up the entire height of the ribbon. That's right, we're going into the features that are small. So between the first two extrusions here, that is the extruded base, the revolved base, up next is the swept base. So between the extruded base and the revolved base, you can cover about 70–80% of the material that you try to make. The swept base is specific but very useful under those specific circumstances. And to give you an example of a situation where that sweep is useful, let's consider an invalid value for registry. It's important when you are invalidating a registry that you do so with reckless abandon. That way you get a full sense of what the file is that you're trying to open. Apparently I have to open this in Paint. That makes sense. Okay, consider this handle. Are you considering it? Liam, are you fully considered?
I am fully considering this.
Okay. If we wanted to try to get a handle on modeling this, we would have to approach it from a couple different directions. We could break it into 3 linear extrusions if we wanted to, and then 2 revolved extrusions, but there's an easier way. There is. That easier way is the swept extrusion. The logic behind the swept extrusion is that if we draw a cross-section of the shape we want to extrude and then a path for it to follow, we can create 3D models that are like a linear extrusion, except the extrusion doesn't have to follow a specific line. So if we were to approach that in SolidWorks, we have to create 2 sketches, at least in theory. Those 2 sketches will make up the cross-section we want to extrude and the path along which to extrude. The cross-section has to start or end the path. So in this case, I'm going to draw my sketch representing the path to extrude, starting so that the edges of the handle are on the top plane. That way I can draw a circle on the top plane and start or end my sweep with that circle. So I'll create a new sketch. I'll go to the top plane. I'll draw a circle. I'll arbitrarily choose left as the side that I want to start my path on, and I will apply a dimension to that circle. What's the diameter of the material in the handle?
0.05.
Correct, 0.05 meters. So I'm going to go 0.05 meters, which is 50 millimeters. I'm going to position that so that it is centered, and then I'm going to apply a distance between the center of the handle and the origin. What distance should that be?
0.25.
Correct. From the top view, I can see that I want the distance between the center points. Remember that this indication on that sketch is an indication of the center of the sides of the handle. That distance between the center points is 0.5, therefore the distance from the center of the handle to one of the sides would be 0.25. So 0.25 meters. Look at that, 250 millimeters. Convenient. Now I have a fully defined circle, but if I jump back out to 3D space, you can get a sense of where it is that I'm going to be looking at this. So that circle represents the path to follow when my handle is actually extruded. Does that logic make sense? So we drew on the top plane. Our next sketch is going to be on the front plane, and that's going to be the path to follow. So we create another sketch. This is sketch number 2. This one's going to be on the front plane, and this sketch is going to be the center of the handle. So I'm going to draw some arbitrary shapes here. I'm going to start with a line. I'm going to include a circle, because we haven't talked about fillets yet. I'm going to draw another line. I'm going to draw another circle, and then a last line. And then at this point, it's just a matter of applying dimensions, relations, and trimming off the edges. So I will tell SolidWorks I want the end point to be horizontally aligned. I will trim off the inside edges of these circles. I will apply tangent relations to pretty much everything ever so that the line follows a tangent of the arc. I will apply an equal relationship between the 2 arcs. I will right-click this top line, select the midpoint, control-click the origin, apply a vertical relation. That way the handle is centered. And you'll notice that because I started my path in the center of that circle, and because I told SolidWorks this vertical line needs to be or excuse me, the horizontal line needs to be vertically positioned above the origin. And because the arcs are the same distance, this right line is now fully defined. I can't move it left or right. So I can continue grabbing dimensions where I need them. Next one's going to be the radius or diameter of the arcs making up the sides of the handle. If the outside edge has a radius of 0.125 and the inside edge has a radius of 0.075, what radius do I need to apply to this arc? It's going to be in the middle of those two. So halfway between 0.125 and 0.075 is 0.1. You did it. So 0.1 meters. It's going to be a radius, 0.1 meters. And then I need a height. I recognize that from my side view, I need a height of 0.25 meters up to the center, which is appropriately this line here, 0.25 meters. Now my line is fully defined. Questions on how we got to here? Okie doke. Now I can exit my sketch, and I have two fully defined sketches. I now have everything I need to create my sweep. So I'll go back up to Features. I will click on the Swept Base, and it is prompting me to select two sketches. The first sketch, this one indicated here with the little blue circle, is the sketch to sweep, which is my circle. I could either go in and select the sketch containing the circle, or I could actually just click on the circle in the 3D view. Then it prompts me for the path to follow. This is going to be the other sketch we created. Now when I click OK, I've got a handle. How neat is that?
That's pretty neat.
It's pretty neat. Questions? So I will point out that if you look into the features under this sweep, one of the options is to use a circular profile instead of actually defining a sketch to define the shape to sweep through space. In this particular case, because the cross-section of the handle was a circle, I could have used the circular profile. I could have just said, hey, what was that again? 0.05 meters in diameter. So I could say 0.05 meters, and this would end up with the same thing. And it doesn't even require that first sketch. Apparently, when I delete that sketch, because I referenced it in the other sketch as the endpoint of the line, it disappears. But for example, I could use that sketch to define more interesting geometry if I wanted to. Like if I switch this circle to a construction line, and I switch to, I don't know, like a hexagon or something. Nothing cooler than hexagons, that's my motto. So I'm going to tell SolidWorks that the edge of one of the nodes in the hexagon should be horizontally aligned with the origin for no reason in particular. Now look at that. That's a much cooler handle, right?
Yeah, yes.
Right. I mean, the world is my oyster at this point. Any enclosed contour would be okay. If instead of a hexagon, I wanted to go with like an octagon, which is cooler objectively than a hexagon, or if I wanted to like draw the shape of, I don't know, this thing, as long as it starts or ends on that path and is an enclosed region, I can create a handle with that geometry. I would argue that this might be appropriate for a very specific circumstance where you're trying to apply a nice rounded edge on top of some very crude edge to a part that you've ground down, made out of metal, that you don't want to go through the process of trying to round over manually.
Sounds like a personal experience.
Perfect. Questions on that? So if you were trying to model a shape that had more complicated geometry than just a linear extrusion, the sweep is often useful for that. So that handle on the cup that we made in class last week, we could have done with a sweep. Doing it with a sweep would allow us to define maybe some softer edges so that the handle was more of an arc and less of a rectangular rounded edge shape. We have options with the sweep that we wouldn't have had otherwise. Let's try another example. Let's try to use the standard dimensions for a paperclip to make a paperclip. So this is the metric standard for a paperclip. The diameter of the steel used is a little bit under 1 millimeter, and these are the dimensions. So I'm going to draw this shape as a sketch representing the path to follow, and because the cross-section of a paperclip is a circle, I don't have to worry about trying to draw a secondary shape. So I can go back into SolidWorks. I can open up a new part. I will arbitrarily pick a sketch on the top plane, now I can just start mapping out some geometry. So I'm going to draw 3 circles. I'm going to connect them with 4 lines. I'm going to try to remember that so I don't have to Alt-Tab quite so many times. I also recognize that my origin in this particular sketch is given as being in the center of the bottom circle. So I'll apply a circle, I'll apply a circle, I'll apply a circle. I will ignore a phone call from spam. I will draw some lines like this maybe. Beautiful looking paperclip. Now I can trim and start applying some dimensions. So first up, the bottom diameter is 9. That'd be millimeters. I'm in millimeters already, so a diameter of 9 would be a radius of 4.5. Second circle has a radius of 3.9, 3.9. Top circle has a radius of 5, 5. Now I need some distances between the top circle and the bottom circle. I'll dimension off the center point. That'd be 31. And then a dimension between the middle circle and the bottom circle of 15. Go with 15. Dimension of the right arm. This one here is 22. Thank you. You're right. You're totally right. 22. 15 is the left leg of that middle circle. That would be 15, John. That doesn't start with a 2. And then 24, 31, 22. So, yeah, I think we've got the shape roughly defined. Now I can add in some relations to fix the shape of my, quote, bent paperclip, unquote. If I apply some vertical relations, now I've got the shape. And then again, because this is a circular cross-section, I don't have to define a second sketch. I can just go up into features, I can select swept base, switch it over to circular profile, and give it a diameter. Standard paperclip diameters are a little bit less than a millimeter. Let's go with 0.9, and boom, we've got a paperclip. Easy peasy. Do you get the concept of the swept extrusion? Can you imagine in the theater of your mind situations where you may want to use it? Yes, that is the only example, building a paperclip. I look forward to all the 3D prints of paperclips I'm going to get later this semester.
Making a donut, so you got to make a handle on that cup.
True, true. Let's leave that for an exercise outside the scope of this particular class. Okay, that's the swept extrusion. After the swept extrusion, we've got the lofted base. That one is fun. So the lofted base is doing a lot of math for you, and it makes your life a lot easier. The general concept behind the lofted base is that it connects profiles that you've established. So let's say, for example, I wanted to define a duct that attached to a fan, and I wanted that duct to mount onto a fan that had a circular profile, but I want the outlet of the duct to have a rectangular profile. So what I would do there, let's just go look up some standard fan mounting specs. Say 80 millimeter fan mounting. So if I open up, let's go with this one here. If I wanted to make a mount that meshed with the mounting geometry on an 80 millimeter standard fan, I could draw this shape and extrude it. So if I switch back over to Solidworks, I'll draw on the top, and let's draw a square to begin with, and then let's Alt-Tab into the right thing. Let's go with a circle in the center, just for convenience. And then 4 circles on the outside edges. To make this a different example than some stuff we've done before, let's apply some midpoints here.
Would you need guiding lines for that lofted extrusion?
Oh, we'll get to that. And then let's make that center circle 90 millimeters. Let's establish the outside as 80. That would be 80. Let's actually go with 76. That looks much more better. And then apply an equal relation between the top and the sides. let's go with let's go with circles here, 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 and here, and then apply some relations. These need to be vertical. These need to be horizontal. These need to be vertical. These need to be horizontal. And I will point out that this type of situation could be made more or less convenient with some construction lines. For example, if I wanted to connect all these circles together, then I could do things like, hey, the midpoint of this line needs to be vertically aligned to the origin, or I could say these two lines need to be horizontal instead of having to center click all those circles and apply relations. I could also apply an equal relationship between those two construction lines. And if I do the same midpoint relation with the origin on the side, now I've got mounting holes that can be resized, and they're always going to be centered. So if I go back into my specs, that's 71.5 millimeters across, 71.5. So if this was the particular shape I was going for, what did you break? Oh, right. That needs to be on the origin. Yes, that's what I wanted. So what I'm doing here, by the way, if you click and drag the circle, again, that's the easiest way to figure out what's not fully defined. He said, watching it mysteriously go from blue to black. Okay, let's... Huh. Well, that's weird. Anyway, let's just ignore it and hope it goes away. I'll apply some diameters to these little circles. Let's make them all equal. Apply a diameter over here. Let's go with 4 to 4.7. Halfway between 4 and 4.7, 4.35. Yeah. Okay. Now I've got a fully defined sketch. So if I were to extrude this linearly, I have, maybe in the downward direction, I have a nice little mounting flange for a fan. If I wanted to try to connect this to a ducting system, it would be fine as long as specifically what I'm doing is extruding straight off of that circle. Like, for example, if we wanted to create a duct off of this flange that had a circular cross section, let's say it was, oh, I don't know, 2.5 millimeters thick. So what happened is I modified my sketch. It doesn't know what my contour is because I didn't initially define it. Now I'm telling it what it was just to keep it happy. So if I go back in and extrude off of my sketch and say, hey, this time I want to extrude specifically this inside annulus, maybe 500 millimeters. That should be nice. Now I've got a duct. Cool. I could do the same thing I did with my handle and create an arbitrary shape for this duct to sweep through space if I wanted to. But the problem is, if I want it to change geometry, that gets a little bit complicated. So let's start with this circular shape, this two-dimensional donut, this annulus, if you will, and let's convert that into a rectangular cross-section. So what I'm going to do is create another sketch, which is going to be the end of the shape that I want to connect. To do that, I need to draw on something, and I don't have any other geometry away from the center. I don't have other shapes to draw on. I don't have edges of a part that already exists. So what I have to do is create a new plane. The way that I create a new plane in Solidworks is up here under reference geometry. I can create another plane, and I have to tell Solidworks where that plane is. I'm going to position it off of the existing cardinal planes. So I want a plane that is parallel to the top plane, and let's say it's 100 millimeters away, maybe 150. Now, at that point, SOLIDWORKS has enough information to fully define the position of that plane. If it's a parallel offset, it doesn't need any more information, because remember, the plane extends infinitely in all directions, despite the fact that it isn't indicated as going infinitely in all directions. Now I have another plane. So I have my right plane, I have my top plane, I have my front plane, and I have plane 1. That's a good looking plane, and that's just plain to see. I could sketch on that in the same way that I could sketch on any of the cardinal planes. So if I switch to a top view, I'm now sketching on plane 1. So I will draw a rectangular cross section this time. So let's say I want to connect to a shape like this. So I'm going to establish some midplane connections to the origin in the same way that I did earlier. This would also be a good opportunity to use the offset tool if I didn't want to draw two rectangles. So rough shape like this. Instead of using the offset tool, I could create construction lines to tell Solidworks that whatever the offset is in one direction, it should be in the other one as well. So I think I had made the other one 2.5 millimeters thick. I'll make this one 2.5 millimeters thick as well. And then let's apply some arbitrary dimensions. This should be 35 millimeters vertically and 175 horizontally. Okay, so now the objective is going to be, I want to connect this circle here with this rectangle here. This is the situation that the loft is built for. If you go up under Features, you select the lofted base, it makes you select profiles. So right now, my sketch is hidden inside of the first extrusion that we created. This is because I used the sketch to create that extrusion. It doesn't think I want to see the sketch anymore. If I do want to see it and reference it, I can show that sketch again. Now if I click on the outside circle from that initial sketch, and if I click on the outside circle of that initial sketch, okay. Okay. If I click on the outside circle from that initial sketch,
You should make a new sketch.
nah, that would be entirely, I'm stubborn, man. I gotta make SolidWorks do what I want. Okay, well, let's just delete it. The case of the mysterious sketch. So again, if I click on the outside circle from my initial profile, and guys, how's it going?
Just make it a new sketch.
Yeah, I could. I could totally do that.
You just don't want to give in to SolidWorks.
I don't want to give in to SolidWorks. I will make it conform.
I usually give up and just do that.
Yeah. Okay, let's define the other contour
Wait a
first.
second, I think there's this thing in Sketch that you can do. Like you click on the outside circle. Row sketch. No, like on the top. It's physical. There's a thing that you can make it, I did this once. It's the,
I appreciate that. Okay.
I know.
So I click on the outside circle. I click the check mark to indicate OK. I define the other contour. I click the green check mark indicating OK. And look at that. SolidWorks shows me a preview of the shape it's going to generate connecting the two. So my SolidWorks on this computer was set up to not show the selection manager. So when I clicked on the shape, it just grabbed the entire sketch. Luckily for us, that was a learning opportunity to learn how to re-show the selection manager. Once we got the selection manager back up, this is, of course, the easiest extrusion to create. Now, if I click OK, it connects that geometry in the easiest way that it can generate. So the least complicated extrusion is what it creates. If I wanted to continue that, I could, for example, indicate some starting and ending constraints. I could tell it that I wanted it to specifically extrude the initial and end points of that loft so that they came away orthogonally to the sketch that I had drawn. Something like this might look more organic. Now if I wanted to create a cut, I could do the same logic except with a lofted cut instead of a lofted extrusion. And this time I have to go back in to my loft to be able to see the sketches. And like I did earlier, I have to show the sketches in order to be able to reference them. So if I reopen up my selection manager. And then in order to be able to grab just that center circle, a lesson that we learned very painfully about 2 minutes ago, and select my 2 inside edges, then I apply the same constraints as earlier, we come up with the same geometry, just spaced 2.5 millimeters away. Now I can go back and hide these again if I wanted to. Make it a little bit prettier. I could hide the plane too if I didn't want to see that. I could go back in and sketch out something to interface with on the edges for aesthetic reasons. I could go back in and extrude out my initial flange, something like this. I could extrude off of the secondary sketch too in the same way. If for some reason I wanted this to establish a laminar flow regime, I could have a straight section. And I realize that this is a specific case. The loft is a specific tool. In the event that you want to correct geometry, you can use the loft to define edges. The other extrusion is the same logic as the lofted base, except instead of defining contours to connect, you define edges to follow. The lofted tool is something that you may only use once or twice in your experience with SolidWorks unless you work in a very specific type of industry. The boundary tool is even more selective. The loft tool and the boundary tool can be used to create essentially the same geometry. Just a different way of thinking about it, if you're defining the contours versus defining the edges. Okay, so naturally at this point, if this was actual airflow that I wanted to try to model, I would go through and fillet everything. To try to limit drag, I could, let's go with a 2 millimeter fillet. Ah, that's why. So some nice fillets on the inside edges. Maybe some fillets on the outside edges. Because as everyone knows, applying fillets to everything is what you do to indicate that you are a very proficient 3D modeler. Yep. Let's just abandon this part. Next up, moving our way across the ribbon, we've talked about the fillet a little bit. Let's consider a shape that is a little bit easier to apply fillets to. Let's go with a nice standard cube. The standard cube shouldn't give me any headaches. Surely it won't. Mid-plane extrusion, I don't know, 100 millimeters. There, cube. The cube is a place of safety. Let's think inside the box created by the cube. I want to establish some fillets on the edges. I can do that by using the fillet tool in 3 dimensions and select whatever edges I want to apply fillets to. The fillet tool is also useful for defining fillets on the edges of all faces. If you click on the entire face, you can define those edges. Similar to the fillet tool, we have a chamfer tool. I will point out that I learned this tool using the name chamfer. Depending on where you went to school or what decade you were born in, people also refer to this as chamfer or camphor, which is incorrect, of course. Chamfer is the only correct pronunciation of that word, but I will point out if you're watching other YouTube videos trying to learn how to do stuff in SolidWorks and you hear them reference a chamfer, it's the same thing. Sort of like turbine versus turbine. 2 pronunciations entirely regional in their pronunciation distinction. One is right, one is wrong. I will also point out that underneath the fillet tool, you have some interesting geometry options. If you wanted it to be a symmetric fillet, so that you ended up with a nice arc, for example, You can use the symmetric parameter when you're generating a fillet, but you can also create asymmetric fillets that are longer on one side than the other. And in the event that you have something really stubborn that you just can't get to fillet, there's a special tool called Fillet Expert, which incorporates some of the other tools in SolidWorks to try to figure out what is wrong with your extrusion and fix it when it's generating a fillet. So if you have geometry that breaks as the result of creating a fillet, the Fillet Expert is great at correcting that. So in the event that you're ever struggling with a fillet and you can't get it to work, sometimes applying the Fillet Expert is useful. I'm not going to make you do many fillets in the homework assignments for this class because it's kind of a nightmare for my grader to try to grade. So that's more of a piece of information to file away in the back of your brain for learning in the future. The only other real tool I want you to get proficient at within working in 3D geometry is the pattern tool. So the logic behind the pattern tool is if you create an extrusion, like, I don't know, let's go with something entirely different. Let's go with something round. If I sketch on the top plane something round, and I extrude up, I have a cylinder. Let's say that on this cylinder I had created an extrusion. So I'm going to draw on the top plane. I'm going to draw some real specific geometry that really represents the thing that I'm trying to make. Maybe something with like lots of points. Maybe something asymmetrical, just to make it real hard to want to go through the process of trying to repeat this. So if I had some feature that I had created painstakingly and I didn't want to have to repeat myself, I can recognize opportunities to incorporate rotational symmetry, just like we had earlier with our previous extrusion. So maybe some arbitrary shape that looks like this. Let's say that I wanted this one feature to be patterned around the cylinder. I can use a circular pattern for that. A circular pattern works off of defining a thing around which to extrude and a number of features to recreate. So for this particular case, because I have a cylinder that I'm revolving around, I can use the outside edge of the cylinder or one of the top edges to define the thing around which to revolve. So if I were to say, I want two of these to be equally spaced around 360 degrees, and I select the feature I want to extrude, this thing. Now, if I wanted to switch that to 3 or 4 or 5 or 50, SolidWorks can handle recreating that pattern as many times as I want. So 5 of these arbitrary shapes, for example. This is all well and good if I'm revolving around something that already exists. The same logic can be applied around geometry for which you don't have something to revolve around. So let's say instead of a cylinder, I was creating, I don't know, some sort of hip new fidget spinner design, and I had to find something around which to extrude, like this maybe, real good looking fidget spinner. I like the way it has no interesting edges. That's really my favorite part. So I'll apply some arbitrary dimensions. Maybe this is some sort of 5mm thickness. And that, yeah, that looks good. I like that. Now, when I go to try to create a pattern from this sketch, I don't have anything to revolve around. That's all okay if I'm creating a linear pattern. I can reference the existing planes for that. I could say create a linear pattern in the right direction. Pattern these 100mm apart and make a bajillion of them. That would work just fine. But it doesn't work. Okay, that would work just fine. But it doesn't work for a circular pattern because the circular pattern needs something around which to revolve. So just like earlier, we had created a plane by going up to reference geometry and selecting plane. I can define an axis around which to revolve. The relevant axis generation for me here would be around my plane, since my origin was going to be the thing that I wanted to spin around. So I could say, for example, at the intersection of the right plane and the front plane, that would generate an axis at the intersection of those two planes. I could also select the origin itself and tell it that I wanted it to be orthogonal to the top plane. That would also generate an axis that would work just fine for my purposes. But now that I have an axis, I have a thing to revolve around. So I could go back up to circular pattern. I could select my axis, and I could say, hey, revolve that extrusion we created earlier, and make, oh, I don't know, 5 of them, or, ooh, 6. 6 is better. That way, no one has the ability to actually spin the fidget spinner, so it'll be nice and stationary. I like that. Could hide my axis, and there we go. The reason that I drew so much attention to trying to figure out how to pattern that in 3D space is because SolidWorks treats two-dimensional patterns and three-dimensional patterns differently. The same way that it treats two-dimensional fillets and three-dimensional fillets differently. So we just talked about the feature that exists within the 3D space. If you're creating a two-dimensional pattern, let's go in and create a sketch this time, and your pattern consists of the same setup, except this time we are in a sketch and not talking about features. So I've got the same arbitrary shape. I have the ability to create a pattern within the sketch. And the way that SolidWorks handles a pattern of entities within a sketch and a pattern of entities within features is different. Because it can move around your references within the sketch, but it can't do that for 3D geometry. So let's consider a situation where we wanted to create a pattern that was referencing itself. So if I wanted to create a circle in SolidWorks, and I wanted to pattern hexagons within that circle, let's go with a 200 millimeter circle, and let's create a pattern of hexagons. So maybe you're 3D printing some texture that you're trying to use for solidity, or maybe you want to create a whole bunch of neat cutouts in a shape that doesn't need that much material. So if we were to create a couple of hexagons here, I could tell SolidWorks I want to establish a pattern. Let's force it to be a pattern that is positioned with hexagons that have an inside diameter of, oh, I don't know, 1 inch. And let's say that the distance between the hexagons is 0.1 inches. Now let's apply some equal relationships between those construction circles. So now I've got these two hexagons that I'm going to pattern. If I were to create an extrusion, so here, for the sake of argument, let's approach this as an extrusion first. So I'm selecting the entire circle, I'm extruding it. I'm going to go up and create a linear cut using that same sketch as earlier. I'm going to select the contour to cut as being the hexagons themselves. I'm going to cut out those two hexagons, and I end up with this arbitrary cutout. If I were to try to create a linear pattern from this cutout, I could say, hey, pattern that feature in the X direction and pattern that feature in the Y direction with 8 inches in the X direction that are 2 inches apart and 2 instances in the Y direction that are 2 inches apart. Something like this. That's fine. I have created a pattern from the feature. The problem with that is I have to do math if I want to figure out where these spaces should be relevant to one another. So I want to define a distance between, let's say, this hexagon and this hexagon that was 0.1 inches. I have to input the correct number into this dimension. So, for example, this doesn't look quite like 0.1 inches like this one was over here. So I can move that back, maybe from 50.8 millimeters to, I don't know, 49 millimeters. Does that look right? Maybe 48. I could establish the cut and then go up and measure it. I could say, okay, the distance between this line and this line, that is 2.2 millimeters. And what I want it to be is 2.54. Okay, so I have to add 0.34 to that pattern spacing. So 48.34. Okay, that should be the right distance, right? If I go up and measure it, the distance between this thing and this thing, that's okay, that's 2.49. Ah, man. And this one's 2.54. That means I have to add 0.05 onto it. Ah, got to go back up into my linear pattern. Got to add 0.5 back onto that. Maybe something like 48.84. Is that right this time? Oh, man, if I go measure that, distance between here and here is, oh, that's not what I wanted. That's 2.93. Oh, that's still wrong. And then even if you get close, you might be rounding. So I could add some more decimal places to my measurement and say, okay, I want to see like a whole bunch of them. 2.9268072 and 2.54. Okay, I can subtract that. I can figure out what the spacing should be. But then we have to get into the y spacing. Oh man, if I want to get this 0.1 inches away from here, I'd have to do all sorts of math. I don't want to do math. So the convenient thing about creating a pattern within a sketch is that you can have the geometry for the pattern reference the sketch. So let's apply that same logic to this hexagon sketch that I had created. Let's pattern that. So I'm going to create a linear pattern within the sketch. I'm going to tell it to pattern these entities. I'll select the hexagon edges. And I will tell it to pattern them such that this is, oh, I don't know, 50 millimeters in the x direction and, oh, I don't know, 100 millimeters in the y direction. That doesn't quite seem like 0.1 inches, but I'm sure it's probably close enough to start with at least. Something like this. So I created a pattern. I told it an initial distance, but that distance isn't in force. I can drag around those hexagons. I could fix these initial seeds for my sketch, let's say like this, and then grab this right hexagon and drag that around. Whee! And just like I can with any other sketch entity, I can dimension that. I could say, hey, Solidworks, the distance between this point and this point should be 0.1 inches. And it'll move the geometry for the pattern to follow whatever enforcement I had. I could do the same thing up here. I could say, hey, this distance should also be 0.1 inches. Now I've got equal spacing. I can also see which edges aren't fully defined. That's going to be a vertical relation. Now I've got a whole bunch of black hexagons indicating they're fully defined. These numbers that are appearing on my sketch are how many times to pattern that entity. So 5 in the x direction might be more than I want. Maybe something more like 4 will get me across the circle. Maybe something in the y direction of like 7. Yeah, that looks pretty decent. Can go eliminate the fixed position and then go drag these around. Maybe something like that. It's not quite centered. Let's just, apply a center relation to the origin. We can do that because it's a sketch entity. So I'll tell SolidWorks this arbitrary hexagon should be positioned around the center. Something like this. And there we've got a sweet arbitrary pattern, fully defined in space. That doesn't quite look right. I think it would look better if it was spaced over a little bit. Oh, that's cool. I can just go eliminate those relations. I can drag this around a little bit more, maybe something like this. And oh, let's position off of that hexagon. Something maybe like this. And oh, that doesn't quite cover the entire circle. That's okay. I can change the number of instances. I can switch this X pattern to 5 instead of 4. And maybe 1 more in the Y direction. Maybe 8 instead of 7. Something maybe like that. That looks pretty good. Now I can create an extrusion from this sketch in the same way that I could any other sketch. So what I had initially created with that initial example was a cut, and therefore it'll break in my new sketch. No, it's fine. It's a potato of a computer, I know. So that warning that just popped out, in case you're curious, is, hey, we're showing a lot of relations on the screen. Your computer might go faster if we eliminate some of those relations, and I say it's fine. SolidWorks. You don't have to worry about it. And there, we've created an odd, arbitrary honeycomb shape. My point is, you can create patterns within a sketch. You can create patterns of features. They are two different things. They are useful or not useful in certain circumstances. The big advantage of creating a pattern within a sketch is that you can reference the sketch. You can apply relations, you can apply dimensions to it in the same way that you could any other sketch entity. You can't do that in the same way with a pattern of features. So, we've talked about fillets, we've talked about patterns, we've talked about reference geometry. The last real tool you have to be able to use here is a type of pattern called mirror. It's so important it has its own dedicated button, but either one is just fine. If you create something in SolidWorks that has symmetry and you want to just pattern it, you can use a pattern like a linear pattern, or in the event that you have mirror symmetry, you can generate a mirror. So this weird honeycomb thing that we created, you know, I don't like the way that it looks. I think it would look better if we were to enclose that circle. It's fine. Don't worry about it, SolidWorks. I think something like this looks better. That's way cooler. Okay, so if this shape had an asymmetric symmetry to it, and I wanted to establish a mirror, I can go select a face around which to mirror. Let's go with the, oh man, it'd be nice if we had a plane around which to mirror. That's cool. I can just create a reference plane, maybe over here, and then generate a mirror using that plane. I don't know what I did to anger SolidWorks today, but it is just not having it. Yep, that's what I wanted. Dude, I'm gonna get this. You can do it. Come on. You can do it. See, we made a mirror. That's useful. Sometimes. Now we have two weird shapes. So speaking of weird shapes, your homework assignment this week is going to be to create 3 parts, which should look pretty familiar. They are specifically the 3 parts that are in the YouTube videos that are posted on the YouTube channel. That's intentional. If you are having trouble creating these geometries, I want you to be able to follow along with the video. The goal of this week's homework assignment is to get you more proficient at applying these same tools over and over again. So you don't have any choose your own adventure parts, you just have these 3 shapes. Again, you're going to be submitting a part file and an image. If you want to do a choose your own adventure part, that's fine. Feel free to submit it to the Dropbox and have it ignored forever. See you guys next week.